Hello everyone, my name is Xiaoyong Zhu and I'm one of the core developers working in Feathr team. Today we are going to talk about the motivation for Feature Store and I'll introduce Feathr and the highlights of Feathr itself. After that, I'll talk about the architecture, show a brief demo, and then talk about the roadmap. So first, why would we actually need a Feature Store at the very beginning? Because we all know that machine learning models, they are composed of both code and data. For data, they are from the real world, never stops change, and you can't control how it changes. And because of that, we meet a lot of the data problems in AI world. Specifically, we categorize them into 5 different categories. The first one being that the features, they are not reused, and it's really hard to be tracked and meet compliance standard. The second one being that the feature definitions, they are inconsistent across different teams. For example, you have one team that have a column called UID, and another team called user ID, and a third team called profile ID. And it's really hard to standardize them across different companies and across different orgs. The third one being getting features into production is very hard because you need to go through all the machine learning ops environments in your company. The fourth one being the features, they are inconsistent across training and serving time across online and offline environments, which causes a problem that we call it online-offline skew. The final one being that the quality of the feature and the data, they are changing over time, so that we need the humans in the loop to monitor all the components. Because of that, the community have developed a concept called Feature Store to solve all those different problems. Specifically, a feature store usually has 3 components. The first component being the feature ingestion and compute part, where it usually has a batch provider and an online provider. For batch provider, it usually provides a high throughput API for you so that the data scientists can access all the historical features with high throughput. And for the online providers, usually a data scientist can use it to access all the low latency features during inference time. And below that, it's usually a feature ingestion engine, for example, either a batch engine or a streaming engine, so that you can ingest data from different sources, such as HDFS or Kafka. And after you have ingested all the data, you also want to define your features in a centralized place. That is usually called a feature registry and governance component. Because of that, all the features, they are centralized in a single place and they can be reused or can be tracked so that it can meet the compliance standard. And we also use this component to make sure that the feature definitions, they are consistent across different teams. The final component in your feature store is usually what's called feature monitoring component. In that component, usually a feature store has monitoring pipelines to monitor the feature distribution just to make sure that the features are calculated as expected. After we know what is a feature store, I want to introduce Feathr, a battle-tested feature store built by LinkedIn. If you use the LinkedIn app or use the LinkedIn website, you always see that, for example, the jobs recommended by LinkedIn or the top blog posts that you might be interested in. All those kind of use cases, they are supported by Feathr in the backend. I've also listed a couple of the engineers' blogs so that you can deep dive more. Feathr is widely used within LinkedIn. It's serving features for most of the machine learning applications within LinkedIn and supporting hundreds of training workflows. LinkedIn has been using Feathr in production for over 6 years and have a dedicated team improving it. During the design, Feathr really focused on usability and flexibility. One case study we've done internally is that one of the large custom feature pipelines can be reduced from thousands of lines of code to only 10 lines of code because of Feathr. The feature compute and feature drawing performance also increased a lot compared to application-specific custom feature workflows. All of those enabled feature sharing across teams, and that leading to the final business metric gains. Feathr was open sourced and announced in April 2022 so that more end users can use it in their internal systems. Next, let's talk about the highlights of Feathr. First, Feathr has really rich UDF support. It allows for highly customizable UDFs with native PySpark and Spark SQL so that the data scientist learning curve will be very low. Below is an example where you can use the PySpark functions or write arbitrary customized UDFs within Feathr. Feathr also have rich support for point-in-time joins and aggregations. For example, Feathr has really high-performance built-in operators designed specifically for Feature Store. Those include point-in-time joins, the time-aware sliding window aggregation, lookup features, and they all come with a point-in-time correctness. One of the case studies we've done internally was from feature ideation to production phase, it reduced from a couple of weeks to a couple of hours because of the Feathr built-in operators. Feathr also highly encourages feature reuse. One of the important things in Feathr is called derived features, which allows end users to build another feature on top of an existing feature, so that features can be reused across different organizations and different teams. Feathr also supports reading from multiple sources at once, including the stream source. For example, you can ingest data from an HDFS source, from Snowflake, or from Kafka. Feathr itself also have rich type systems designed specifically for machine learning. For example, Feathr has built-in support for embeddings. For example, you probably have embeddings for user activities, or you probably have embeddings for content, etc. Those embeddings can be reused across an organization within Feathr. This system also helps end users to reduce the time to deliver complex embedding features so that the end model performance can be boosted. Feathr also supports common machine learning types such as categorical data or categorical set of data. Feathr itself really focuses a lot on scalability, security, and compliance. For example, for scalability, Feathr is capable of processing tens of billions of rows and can easily scale to petabyte scale data. It also has built-in optimizations such as Bloom filters, sorted joins, and the other built-in joint plan optimizers. It's cloud-friendly, so it has a scalable architecture. Other than that, Feathr also focuses a lot on security and compliance. For example, you can build role-based access controls with Microsoft Purview, or users can also easily build CCPA and GDPR compliant systems with Feathr. Next, let's talk about the Feathr on Azure architecture. Here is the Feathr architecture. At the central, it will be a Spark cluster. Feathr has native support for either Databricks on different clouds or support for Synapse, which is on Azure Cloud. And Feathr have different options for offline stores. One category is the object storage. It can be HDFS, Azure Blob Storage, Azure Data Lake Storage, or simply S3. Feathr also support different file formats, for example, Delta Lake, ORC, Avro, Parquet, and CSV files. Another category of the offline store would be SQL-compatible databases or data warehouses. For example, MySQL, SQL Server, and Snowflake. Those parts are for the offline stores, but you can also connect Feathr to stream sources, such as Event Hub or Kafka. After the data is ingested into Feathr, you can either store them into the offline storage or materialize the data into online storage, such as Redis. Feathr uses Microsoft Purview as the centralized management system, so that you can use role-based access control or store everything together with your data governance system. As I said earlier, Feathr also has a Python client that you can use in different environments. For example, you can use Feathr in Jupyter Notebooks, Azure Machine Learning, or Databricks notebooks. And you can build models using the Feathr offline store and then push them to online environments using the Feathr online APIs. This page has a list of supported cloud services for Feathr. If you feel that there's something missing, or if you want Feathr to support for a particular cloud service, feel free to raise a GitHub issue. Next, let me show a brief demo on how Feathr works. But before getting into the details, let's take a look at the abstractions that Feature Store is expecting. In Feathr, we usually have two personas, one of them being a feature producer and another of them being a feature consumer. For feature producer, their responsibility is to put a feature into a feature store. For example, they can register a feature based on a pre-computed featureized dataset, or they can also register a feature based on a raw dataset using like sliding window joins or aggregations or transformations. They can also register feature based on the other features, which are usually called derived features. So for feature consumers, their job is to get some features out from the feature store. Their focus is usually how to join the features to some of the training data labels or the observation data, or for training purpose, how to compute the historical values of the features using the point-in-time correctness joins. Other cases are included, for example, how to efficiently pre-compute and store and serve the features for online inference.
What we want to do is we probably want to go to the Feathr UI and take a look at all the features that's available in the certain project. We probably want to go to the data sources and take a look at all the sources available in a certain project, or we probably want to go to features, select a project, and view all the features that's available here. We probably also want to know the lineage of the features. So if that's the case, we click some of the features. Let's say we click this one called trip time rounded plus, and then we view the lineage here so that we can get an overall view of all the features available in this project. From this graph, we know that there are a couple features called F location max fare, average fare, and trip distance, etc. in this project. We also know that there are two types of anchors here, aggregation features and request features. The request features are based on the pass-through, which is your observation data, and the aggregation features is based on this source called NYC Taxi batch source. We also know that there are a couple of derived features here. For example, trip time distance, trip time rounded, and trip time rounded plus. They are all called derived features, where they are based on the other features. After we've browsed all the features that's available in the Feathr Registry UI, we can then take a look at how to consume them in either Jupyter Notebooks or other Python environments. Here, let's take a look at the workflow. As you can see, we have divided the workflow into two views, the feature producer view and the feature consumer view. Usually, as the feature consumer, we don't care about how the feature producers register their features. But for illustration purpose, let's also walk through the feature producer view just to make it easier for us to understand. So we have already registered all the features in the feature registry. That's why we can consume it and see it in the UI that we just showed. But from the feature producer point of view, here is the workflow. We have already defined a taxi fare data which contains a couple columns. For example, the pickup ID, the pickup time, drop-off ID, drop-off time, trip distance, and fare amount. And we define two sets of anchors here. Anchors are simply a group of features. Think them a table of features. The first set of anchors is called the request feature, where they are directly based on the observation data. We define a couple of features, for example, trip distance, trip time duration, etc., etc. The second anchor is called the aggregation features, where we want to aggregate some of the features based on timestamps. For example, we want to define two features called location average fare and the location max fare, which are either the average fare in a certain location ID or the max fare in a certain location ID. We also want to define a couple of the derived features. In this case, we define a feature called trip time distance. This is how the feature producer works. And from the feature consumer view, as I said earlier, we usually don't care about how the features were defined. In that case, what we want to do is we just want to consume the features. What we can do is we just specify the names of the features and do a step called feature join or retrieve the features, and that's it. Let's take a look. To use Feathr, the first step is to create the related cloud resources. Feathr has native integrations with Databricks and Azure Synapse, so please follow the corresponding README file in the Feathr GitHub repository to get started. We've already covered the architecture in the prior slides, and the only thing you need to do is to install the Feathr package. After that, we just import a couple of the modules into Feathr, and then define a couple of the configurations that we will need later. For example, if you are using Databricks, you probably want to change the configuration a little bit just to make sure that you are using your Databricks cluster. Or you probably want to change the Azure Client ID, Azure Tenant ID, and Azure Client Secret if you are using the service principals. We will write them into a temporary file, and then those temporary files will be loaded into Feathr. Let's take a look at the data that we'll be using. The dataset is called the New York Taxi driver dataset. It has many columns such as trip ID, vendor ID, pickup time, drop-off time, the pickup location, drop-off location, and a few other columns. One of the most important columns is the total amount, which we'll be using later to predict. Since we have already defined all the features in Feathr and stored them into the registry, as the feature consumer, what we want to do is just to retrieve all the features from the registry. In that case, we will use this API called getFeatures from the registry and specify the project name. And after that, it will return a dictionary. The key of the returned result would be the name of the feature, and the value would be a Python object. After that, we want to query a few features that we've defined in the registry. In this case, we have datasets, or we have the observation data, which has two columns. One of the column being the drop-off datetime column, which will be using the pointing time joins. Another column is called the drop-off location time, which will be the key for Feathr. After that, we will define the features that we want to retrieve from the previous list. For example, we care about those features like the average fare, the trip time rounded, etc., etc. We also need to specify the keys because Feathr needs the key to join the feature data and the observation data. We then also specify the observation data like this, and then call this API called getOfflineFeatures. This will trigger a Spark job. Depending on the Spark runtime and Spark environment you use, you can either choose Databricks or Azure Synapse. Here we use Azure Databricks, and then we can see that the job is succeeded. We can also get the results from the cluster just to view if the result is what we want. Feathr has built-in methods to help you to download those results. And after that, we can see that the results of the joined features, they are already available. Besides all the original data in the observation data, we can see that it helped us to retrieve some of the features, like this feature called its long time distance, and the max fare and average fare, etc., etc. After getting all the features for this particular observation data, we want to train a machine learning model on top of the historical data. Here's the sample code. So what we want to do is we split the training dataset into training and test dataset. We define a machine learning model, and in this case, it's a gradient boosting tree. We then train a machine learning model and then predict the accuracy of the model. As you can see, we've trained the model and it has pretty high model accuracy. After we've satisfied with all the machine learning models, we want to materialize all the features into an online storage. In this case, we are using Redis. We specify the backfill time, which will be the time period that we will backfill, and then specify the Redis sync. We also want to specify the table name so that we materialize the features into a specific Redis table. After that, we will also specify this materialization setting to combine all those configurations together. And then we will call this API called materialize features to materialize all the features into online storage for low latency retrieval. After that, we can use those two APIs, get online features, to get the features for a specified key in a certain Redis table. Or we can also get multiple keys using this API called multi-get online features. That's all for the feature consumer workflow. And now let's switch gear to the feature producer workflow, because we all know that some of the feature consumers could also be feature producers because they want to build features on top of the other features. In that case, let me highlight a couple of the capabilities that Feathr has. As we talked earlier, Feathr has rich support for UDFs. You can use PySpark, Spark SQL, and Pandas on Spark to define your UDF functions. And then you define your source, which has a path and a name for this source. And you also need to specify the event timestamp and the UDF. After that, you can define anchor features. Anchors are just a group of features. For example, you can define trip distance, which is simply a rename of the previous data. You can also define like another feature using Spark SQL functions. You can also do something like cast float or day or week. Those kind of operations, they are directly available in the Spark SQL functions. Beyond that, Feathr also has rich support for all the window aggregations. This is very convenient when defining all the features. For example, we want to know what's the average spend that's happened in a certain location in the last 90 days. In that case, we can just simply define this fare amount, and the aggregation function would be average, and the window would be 90 days. After that, we also want to define a feature, an anchor, to group all those features. We can also define derived features, which are features on top of the other features, just to encourage feature reuse. For example, we want to define trip distance and the trip time duration and combine those two together to a new feature called trip time distance. Those will greatly encourage feature reuse. And finally, we want to call this API called client.buildFeatures just to build all the features into a format that Feathr internally interprets. And then we call this API called Register Features to register all the features that we've defined above into the centralized feature registry so that the feature consumers can use later.
In the project homepage, which has a lot of documentation, or feel free to check out the source code to take a look. Also, we encourage end users to join the Slack channel so that they can interact with the Feathr community directly. The Feathr roadmap is also listed in the Feathr milestone page in GitHub. But briefly, in the short term, we are going to add more functionalities in Feathr. For example, to add feature monitoring, add more input and output resources to have improved feature registry experience, and add more online feature transformations. In the mid-term and long term, we have more support for feature versioning, auto-featureization tools integration, and RBAC support. Again, for more of the up-to-date milestones, feel free to check out our GitHub homepage.